is the Fibonacci pattern. Scientists fed the Fibonacci sequence into a quantum computer and created a new phase of matter that acts like it has two time dimensions. Doing this made storing quantum information less prone to errors. But why the Fibonacci sequence? First, let's go over the main challenge to quantum computing. Unlike traditional computers that quantify information in bits, representing either 0 or 1, quantum bits or qubits can be a 0 or 1 at the same time, allowing quantum computers to process calculations in a shorter period of time. But qubits require an extremely controlled environment, since even a minuscule change can cause the qubits to lose their quantum states, and thus their information. The challenge is to make qubits more robust and stable. Physicists can use symmetries to help the qubit hold up to changes. For example, by pulsing laser light at the qubits periodically, they stayed quantum longer. So scientists wondered if they could make qubits last even longer by adding another dimension of symmetry. Enter the quasi-crystal, which is a quasi-periodic sequence that reflects the periodic sequence of a higher dimensional crystal. An example of a quasi-periodic sequence is the Fibonacci pattern, which is found throughout the natural world, where each part of the sequence is the sum of the two previous parts. Nature's way of maximizing the use of space and resources, from flower seeds to hurricane spirals to DNA molecules. A Fibonacci sequence is ordered without repeating, just like a quasi-crystal. When the laser pulsed following the Fibonacci pattern, the sequence acted akin to a quasi-crystal, resulting in a dimensional flattening. In this case, the flattening of two dimensions of time acted as if it was flowing in two distinct directions, a symmetry that provided for more stable qubits. Is the Fibonacci sequence used in nature for this same reason? Does it not only allow for a more efficient packing of information, but also function as a kind of error-correcting code?